Okay, can I start? All right, good. Hello, my name is Evan Sotalo, and I'm going to give a quick demonstration on a sample model I designed to calculate and manage credit value at risk. The model itself is designed on a visualization platform called Spotfire, and it integrates with other advanced analytical platforms. The goal of the model is to calculate risk measures of loan data that is fed into it, and then interact with the data and identify patterns and subsets of the data that show interesting characteristics. After which, it now conducts a what-if analysis on a highlighted final subset of the data and see how this would affect the risk measures that has been calculated, from which we could analyze the pre and the post what-if values and measure these impacts it would have on the whole portfolio, from which we could further either analyze or propose a specific action to be taken backed by solid data analysis. Now to the model itself. The model measures predefined parameters such as loss given default, expected loss, and credit value at risk on a portfolio of outstanding loans fed into it. The model also calculates the relative credit value at risk. Now, we are not going to leverage on Spotfire and further analyze the data itself. Looking at the data as defined by loss given default, we can see that there are some customers here with high loss given default. We can decide to take interest in those customers and reanalyze that subset of data in terms of expected losses. So what we do is to conduct a drill down on the customers. Now, here we can decide to look at the data by applying very specific defined filters to it, such as the top 5, top 10, top 10%, top 20%, or all data. For this analysis, we're going to look at the top 20%. Looking at these, we can decide to either further analyze this subset of data by looking at it from a different dimension. Here, we're looking at the same subset of data, but in terms of sectors. You can see that certain sectors have high expected losses. Here, you can see that the agricultural sector, the construction sector, and the general commerce sector have high expected losses. As a manager, I could decide to analyze what would happen if I call for a minimum amount of collateral in these three sectors. To do this, I will use the what-if analysis part of the model. I have decided to look at what would happen if I call for a minimum percentage of outstanding loans of 80%. Now to see what will happen to the three identified sectors and in terms of the whole portfolio. Before I conduct the what-if analysis, I want to make sure I include all the data sets this time around. This is so that I could have a more noticeable impact for the demonstration. Now, before I run the analysis, you can see that my pre and post what-if analysis for collateral values are equal, and my pre and post what-if analysis for expected losses are equal. After running this calculation, I expect to see changes in this place. I will now go ahead and click for it to run. So that should be about done now. Okay, we're almost there. Alright, good. Now, you can see the rise in our collateral values and also the drop in our expected losses. This is due to the added collateral posted by customers that previously did not meet the 80% mark in the three sectors we defined. To further illustrate that the data in the three sectors that we identified was changed for this analysis only, we can perform a filter of the data on the other sectors and see that the values are still equal. Here we go down to the sectors, and if we look at the finance and insurance sector, which was not included, you could see that the pre and post what if analysis values are equal. Also, if you look at the general sector, you could also see that the pre and post what if values are equal. But if we look at the agricultural sector that was part of our what if analysis, it should be different. And you can see that. So we take off this filter and continue our analysis. Now we're going to look at the credit value at risk that was calculated pre and the post. Because the credit value at risk was calculated using the Monte Carlo simulation method, and if both calculations are conducted just once, the result might be misleading to show if there was a significant difference or not. The model itself runs this calculation for the pre and post what if analysis values for credit value at risk quite a number of times, and it uses the mean as its final value. It also conducted a test of significance on the two sets of data to determine if at 95% confidence interval there is a significant difference, and then the model included in the model is a p-value. Here you can see that there was a sharp drop in the credit value at risk. Looking at this numerically, you could see that there is a 34.98% on the loss given default drop. There's also a drop of 46.26% on the expected losses. And then there's a drop of 30.25% on the credit value at risk. Looking at the p-value, this strongly indicates that there is a significant difference between the pre and post credit value at risk. Now the manager can now decide if to either continue analyzing other subsets of data or to make a decision concerning this insight he just dug out from the data. Remember, this analysis was done from the comfort of this highly interactive model built on Spotfire. Not once did I leave this environment while using the model. In summary, analytics would always yield insight into data, and the right platforms combined with knowledge and experience would not only make seemingly difficult tasks look quite easy, but also yield insights that could have very telling impact on an organization in general. And that ends our short presentation for now.